So today we are solving rational equations. Solving rational equations. Alright, so we're going to start off easy, and then we're going to work our way up. We're going to start off super easy. What if I asked you this question? If I said something like 7/9 minus how many ninths gets me, I don't know, 2/9. What number would go in for x? A 5. You got that very easily, didn't you? Yeah, and take a look at my denominators. What do you notice about the denominators? They're all the same. If the denominators are all the same, guess what I can do? You can almost ignore them altogether. Right? So you said the answer to this was 5, right? Everybody agree? Right? And I totally agree. In for that x, if I replace a 5, I have a correct equation. If I cover up those 9s, right, and I just, let me make that an equal sign now. So if you just have the equation 7 minus x equals 2, isn't the answer still 5? Right? So basically that's my goal. If I have the same denominator for everybody, I get to ignore it. And then I just solve the equation that the numerator makes. Alright? So that's really kind of my steps. So, step 1, I am going to, now in order to get everybody to have a common denominator, I again want to factor first so then I can see, alright, well what do I need to make happen? So step 1, I'm still going to have it as factor all denominators. And denominators only. So I'm just going to factor all those denominators. Obviously, in my example, there wasn't any to factor, but there will be. Okay? So we factor all denominators. Then step 2, get every fraction to have a common denominator. So, however I need to do that, if I need to multiply by an integer, if I need to multiply by a binomial, whatever I need to do to get everybody to have the same denominator, I'm going to do it. But once I've done it, then I have a problem, just like my example, and then I get to ignore the fact that there's a denominator altogether. So it turns into a much easier equation to solve. So once I have common denominators across the board, now I'm going to ignore the denominators and solve equation in the numerator. I am going to add one more little thing to keep in the back of your mind. There will be times that, let me see if I can give you a good example here. Just really quickly, if I'm looking at number 1 on the sheet that I just gave you, I have no idea what the answer is, but let's just pretend for a second that it comes out to be 6. If the answer is 6, what's going to happen if I plug it back in? What happens if I plug in a 6 into any of these? I get a 0 in the denominator. So I don't know what the answer is going to be when I solve the numerator. I have no idea. But if it comes out to be a 6, I actually have to throw it away. Because I'm not allowed to have 6 as an answer because it turns my denominators into zeros. So it doesn't normally happen, but it's just something I want to be aware of. If by chance my answer happens to be 6, I have to say, you know what, there's actually no answer to this because if I took 6 and I plugged it back in, it wouldn't work. It would turn zeros into the denominator. So, just Keep that in mind. So ignore denominators and solve the equation in the numerator. I'm just gonna say check your answer. Check answer. All right, so let's work this through an example or two on the sheet that I just gave you. Step 1, factor all the denominators. Okay, well, they're already factored. There's nothing for me to do. Get every fraction to have a common denominator. Oh, guess what? That's already done for me too. They're all x minus 6's already. So in step 3, I'm literally going to ignore it, and I'm just going to solve this equation. 15 plus 7x equals negative 6. Much easier equation. I'm just going to solve it like I normally would. I would normally minus 15. 7x equals, what's that, a negative 21. Divide by 7. I got negative 3 as my answer. Is negative 3 going to turn any denominators into zeros? No, so it's a perfectly fine answer.
So that's your answer.
That's my answer. X equals negative 3, that's it. So you try number 2. Same exact idea. Yep. Should anybody else get 5?
Yeah.
Sounds right to me. So again, on 2, all my denominators are already the same, so I'm literally just going to solve 11x minus 14 equals 41, just like you always do. Add the 14. That gets me 55. 5 looks good. It's not going to turn my denominator into zeros, so I'm happy.
So now we look at the denominator.
Yes, so let's look at 3. Step 1, factor all the denominators. Again, there's nothing for me to factor here, so that's a little bit easier. Step 2, I need every fraction to have a common denominator. What will that common denominator be? 7x. The first one already has 7x, so it's fine. The next one doesn't, so I'm going to multiply him by x over x. And what does the last fraction need? 7. So I just multiplied that one by 7. Now that everybody has the same denominator, they all have a 7 and an x. So now I'm really just solving 3x plus x equals 28. How do you solve that? What's 3x plus x? Someone said the right answer. Yeah, 3x and x is 4x. So all I have to do is divide by 4. So my answer is just 7. If the answer is 7, does that create any of my denominators to turn into a 0? No, so it's fine. Bless you. Bless you. Try 4 without me telling you what to do. Oh, if pretend this answer had come out to be a 6 by chance, if you plug it back in, 6 minus 6 is going to give you a 0 in the denominator, and you're never allowed to have that. So if that answer just by chance happened to come out to be 6, I'd have to throw it away because it can't possibly be right. Well, it's not that it's wrong. It really means that that's just not a solution to that problem. Yeah. It doesn't usually happen, but if it does, you just need to be aware of it. Okay, we got an answer for 4. I have no idea what the answer is. But what is our common denominator going to be? 6x, I agree. So the first one needs to be multiplied by 2. This one needs to be multiplied by x. And this one needs 3. Now everybody has a denominator of 6x, correct? So now I really have 4x minus 5x equals 15. 4x minus 5x is just negative x equals 15, so that means positive x equals negative 15. That won't give me a 0 in the denominator, so it's a great answer. Okay. 7. Look at my denominators. They're already factored for me. They already have the 7 times the x minus 3. So that's good. So step 1 is still already done. But I need everybody to be the same. So what am I going to do to the middle one? Yes, he needs an x minus 3 on top and bottom. And then what does the last one need? Just a 7. So I'm really going to do 1 plus 4x minus 3 equals 21. There's my equation, right? Make sure you're distributing that 4. Oh, which I didn't do. Oh my gosh. That's totally wrong. Just kidding around. 1 plus 4x minus 12 equals 21. Oh my goodness. Now I can solve. 1 and negative 12 is a negative 11. Add the 11 over. Oh, good golly, Miss Molly. And then you try 6. Same idea as 5. And we'll see if you do it correctly or not. Oh, I'll stop it in a second. Yeah. Okay, did everybody finish the last one? Okay, you guys we have like 4 minutes. Relax. So on the last one, my common denominator will be 5 times x plus 6. So I need to multiply u by x plus 6. The middle one by 5. And then the last one's already all set. So be careful. Distribute the 2. 2x plus 12. 7 times 5 is 35, so I'll do minus 35 equals 9. So, did you get the following? What's that, 23? Add 23 to both sides. Did you get 16? Hooray!